So in part one of this series, we looked at how A affects all the three different functions in the same way. And in today's episode, we're going to look at the benefits of each of these, of each of the three different forms. So to start off with, the most common one you'll see quadratics in is ax squared plus bx plus c. I'm sure you guys know this already. And so the reason why this form is so commonly used is because the value c is actually the y-intercept. So if we take these ones off for a second and just zoom into the ax squared plus bx plus c, we'll see that for any y-intercept, if c is 1, the y-intercept is 1. So let's just let c play. So for 4.68, the y-intercept is 4.68. Just to prove the point, keep going, 7.52, and it's the y-intercept once again. But why does this happen? Even if it's negative, that's always the rule. C is always the y-intercept because if we imagine the line x is equal to 0, which is this green line, we have to find when this function, so the ax squared plus bx plus c, intersects with this line, y is equal to 0, x is equal to 0. To do that, we have to substitute in x for 0. So in other words, putting in 0 in for here and 0 in for here, the two x's. So if c is 2.8, obviously a times 0 is 0 and b times 0 is 0. So the only thing you have left is this point c, and that's why c always ends up being the y-intercept. So now let's focus on vertex form and its uses. So many times, especially in physics, but in math, they can sometimes ask you, or they give you a real-world application of quadratics, and they ask you to find the maximum height or the minimum height of something, and that's when the vertex form is particularly useful, because the value of h, so not including the minus, so here h is 1, so this would look like 1. So the value of h is the x-coordinate of the vertex. So if h is 1, the x-coordinate of the vertex will be 1. And if k is 1, the y-coordinate of the vertex is also going to be 1. Well, in this case, it's 1. So if we let k play, we should expect that this 1 just increases as k increases. So for 4.6, it's 4.6. And if h increases, it's going to move to the right, because now the x, we have to imagine that now the x is increasing. X goes along this way. So if h increases, the parabola moves this way. So essentially, all it does is you can choose where your parabola you want it to be, since it's very specific values. So if it's in vertex form, what you know immediately is at the point where either it's maximum or it's a minimum. So if a is positive, you know its minimum point, because it concaves upwards. But let's say a is negative a, then it flips. So the highest point, which is the vertex, when a is negative, will now be 7.1 and 1.7. But if a is positive, it's going to be the minimum point. Negative,